Okay students, now our next topic is different type of AC circuits, and in that first let us do the AC voltage when it is passing through a resistor, only resistor which is connected in the circuit. And so here there is a voltage we applied over here, and you can see this is the symbol for the AC voltage source. And so we have the voltage supply over here, V is equals to V naught sine omega t. Now my first thing what I want to do is I want to find out what is the current over here. So because it's only a resistor in the circuit, so we can use the Ohm's law over here, and we know according to the Ohm's law we have V is equals to I into R, and therefore you can say I will then be equal to V upon R. Now V over here, as we know, is V naught sine omega t, so it will be V naught sine omega t upon R. Now V naught by R will then be equal to the maximum value of the current, because this is the maximum value of the voltage. So the maximum value of the voltage divided by R will be the maximum value of the current. So we get I is equals to I naught sine omega t. So this is the expression for the instantaneous current when only resistor is connected in series. So here so we can say if we draw the current versus time and the voltage versus time, or we can say current versus phase or the voltage versus phase diagram. So what we get is, for the voltage we have like this, as it's sinusoidal, V is equals to V naught sine omega t, where clearly, as you know, this is your V naught, and the current graph will also go like this only, because the voltage and current, as you can see, both are having the same phase omega t. So both are having the same phase. This is the maximum value of current, we call it I naught, right? So in this particular case we have voltage and current in the same phase when we have only resistor which is connected through the AC source. Now this is the zero phase, as you know, this must be then pi by 2, this is pi, and this is 3 pi by 2, and this is the complete cycle, that is 2 pi. If I want to show it to you on the phasor diagram, then how can we show it is that we can draw it like this. First of all, we'll always draw the phasor for the voltage, and the phasor for the voltage will be like so. Here, this portion from here to here, if we see, because we'll take the projection on the y-axis because we want the sine component. So this is V naught sine omega t, and as and this is the phase which we are talking about at time t, omega t, which is now this is for the voltage, and for the current then again both are in the same phase, so they both will go together, and therefore we get I over here, and this projection over here, this much is I naught sine omega t. So you can see both are having the same phase, that is omega t, and therefore they move along with the same phase. This is the case when it is purely resistive circuit. Now